Hi everyone. I'd like to present a paper published in Empirical Software Engineering Journal. My name is Agus Sulistia. I'm from Telkom Institute of Technology, Surabaya, Indonesia. I'm presenting here on behalf of Gede Prana, Abhishek Sharma, and Professor David Low from Singapore Management University, and Professor Christoph Truth from University of Adelaide, Australia. This paper is about how to help software developers to find software-relevant contents from various sources by performing cross-platform analysis and by using word embeddings. The first use case we want to explore is when a software developer acts as a knowledge seeker on Twitter. A large number of software developers use Twitter frequently to support their professional activities in order to share and to obtain the latest technical news. However, they face challenges while using Twitter, which related to having to deal with a huge amount of irrelevant tweets produced on Twitter. Therefore, there is a need for a solution that finds relevant tweets that are released in a given time period. In the second use case, consider a software developer who acts as a content creator and publishes a coding tutorial on YouTube. Viewers can leave a comment that expresses their experience with the videos. Digesting information taken from the comments will help content creators to be more engaged with their audience and to improve their future videos. In order to address these challenges, we propose a Sieve, an approach to help automated tasks in a non-software development specific platform. Our approach consists of two stages. The first stage, we learn a word embedding representation from a software development specific platform. In the second stage, we leverage the word embedding built from the source platform to resolve tasks in the target platform. While most research done on question and answer sites based on Stack Overflow data, we believe that relevant domain of Stack Exchange, such as software engineering Stack Exchange, is also a good source for software engineering related terms. So in this work, we use two different platforms, two different sources. The first one is from Stack Overflow, which consists of around 8 million titles and 31 million posts, and Stack Exchange dataset, which consists around 140,000 posts. We then built word-to-vec models trained on both platforms by using skipgram model implemented in Gensim. In the first use case, we show how our approach can be used for the task of finding tweets related to software engineering. In general, we formulate the task of finding software-related tweets as a ranking problem, which rank the tweets in the order of their similarity scores with selected sentences from the source platform. To measure similarity between tweets and selected sentences from the source platform, we need to use the same representation for both texts. We transform each sentence into fixed length vector to represent them. We will explain more about these steps in the next slides. For each sentence in the sampling, in the first step, we convert each word into a vector or value using the word embedding models. The vectors of words belonging to the same sentences are then averaged. At the end, there are n vectors representing the n sentences from the source platform. In the second steps, for each tweet in the dataset, we tokenize it into words, and then we look up its weight from the word embedding models. If a word does not exist in the model, we ignore the words, and then we represent the sentence or the tweets into a fixed length vectors. We then take the average of the word embedding of all words within the tweets. In the last steps, for each tweet vector, we calculate a similarity score between the tweet and each of the sentence vectors. The final scores would be the average similarity scores. We use cosine similarity to calculate similarity between two word vectors. We repeat these steps for all tweets available in the datasets. For the Twitter datasets, we use the same dataset created by Sharma et al. The dataset consists around 6 million tweets downloaded through Twitter API. And then for the metrics, we use accuracy at K, which is defined as the proportion of tweets in the top K position that are software related. For the baselines, we use Nirmal since we use the same dataset as their work. And then we also compare the models with a within platform model trained from Twitter's And also we compare the models with a model that use TF-IDF vectors. As a result, overall, the word embedding models trained on the Stack Exchange perform best in terms of accuracy at K measures. The results also shows that our approach improves all accuracy at K scores of up to 28% as compared to previous approach. The two variants of Sieve, which is trained in Stack Exchange and Stack Overflow, are able to find software-related tweets with accuracy of around or between 0.8 to 1. In our paper, we also explore another use case on finding informative YouTube comments. We also provide discussion about impact of varying various parameter settings and what embedding learns from other software-related domains on the result of our approach. Due to time constraint, for those who are interested, please read the original paper published in MZ Journal. To sum up, we propose an approach to exploit knowledge from rich software development specific platform to automate knowledge-seeking tasks in other less software development specific platform. Based on our experiment conducted in both use case, our approach improved performance of existing work. And in the future, we plan to expand the work to other platform and knowledge source, such as Wikipedia articles, software development blog, README files on GitHub, and software documentation. Thank you. Please email me if you have any question.